Alright guys, in this video we're talking about 2.2. We're talking about, we're talking about 2.2 axioms and properties of probability. Now let's take a look at axioms first. The condition is a given the sample space S. Axiom 1, for any event A subset of the sample space S, we have the probability of A is greater than or equal to 0. Axiom 2, the probability of the sample space is equal to 1. So actually, I think those two axioms are intuitively correct, because when we're talking about the probability of an event, we cannot say, okay, the probability of this event is -1 or -0.5, or we don't say that the probability of this event is like 200%. When we're talking about the probability of an event, we usually talking about it between 0 and 1. Okay. Then axiom 3. If A1, A2, and so forth is an infinite collection, disjoint events. Let me read this part. Disjoint events and A1 union A2 union and so forth. So basically the union of all those events is a subset of sample space. Then the probability of A1 union A2 union and so forth is equal to the probability of A1 plus the probability of A2 plus so forth. If we put it in a form of a summation, it's going to be the sum of I is equal to 1 to infinity probability of AI. So basically, the key point over here is those events supposed to be disjoint events, right? If they're disjoint, we can just add the probability of each event together. Now, once this is clear, let's take a look at the example. Toss a fire die. So, of course, in this case, the sample space would be 1, 2, 3, 4, 5, and 6. And then, if I gave you that the event A is 1, how to find the probability of A? So in this case, the answer, we're tossing the fire die, right? Which means that probability we got each number is the same. So we got 6 different numbers in total. So the probability of getting a 1 would be 1 out of 6, 1 over 6. Actually, this notation is very similar to the idea of relative frequency we went over in the previous videos. So we have that, I'm sorry, I don't know why this pops up. So for the relative frequency is equal to the frequency of one category of one outcome divided by the sum, or divided by sum of all frequency. Okay, so this is This is very similar to the idea of relative frequency. And then if I gave you event B is 2, 3, and I want to find the probability of B. Now, once again, we have 6 outcomes in the sample space, and we have two outcomes, two different outcomes in the event B. So based on the formula we have over here, the probability of B would be equal to the frequency of the event B, which is 2 over 6, which is 1/3. Now, once we have this, what is the probability of A union B? So if we are having the probability of A union B, we want to think of the axiom 3 over here, right? So, but if we want to apply the axiom 3, we can know if they are disjoint or not. In other words, we got to say, do they have anything in common? If they have nothing in common, that means they're disjoint events. Now we have event A is 1 and event B is 2 and 3. Obviously, they have nothing in common, so we have A and B are disjoint. And then we can apply axiom 3 to convert this probability of A union B to the probability of A plus the probability B, which is equal to probability of A is 1 over 6 plus the probability of B, which is 2 over 6. So we have 3 over 6, which is 1/2. That's how we find the probability of A union B. Now, once the axioms are clear, let's take a look at some properties. Property number 1, the probability of an empty set is equal to 0. So basically, if I'm asking, what's the probability of nothing? Of course, that's going to be a 0, okay? So if we get back to the formula of relative frequency, we can tell the frequency of empty set is going to be 0. So we got 0 over 6 is going to be 0. So always keep the idea in your mind, the probability of empty set is 0. Number 2, for any event A, the probability of A plus the probability of A complement is equal to 1, from which probability of A is equal to 1 minus probability of A complement. Why probability of A plus probability of A complement is equal to 1? We can prove this, okay? We prove this. So first of all, let's draw a Venn diagram. So the rectangle over here represents a sample space, and I gave the circle A, and of course the A complement would be outside of the circle A, but inside of the rectangle or the sample space. Of course, the shaded area represents A complement. Now, obviously, we have A and A complement got anything in common, and we have the sample space is equal to A union A complement, right? The sample space is the union of A and A complement. And we know that the probability of the sample space is equal to 1. So if we got back to this formula over here, the probability of a sample space, that would be 6 over 6 would give us 1. Okay? Now, once we know this, we have the probability of the sample space is equal to the probability of A union A complement. And we know A and A complement are disjoint because they have nothing in common. So the probability of A union A complement would be equal to the probability of A plus the probability of A complement. And then, of course, we have probability of A is equal to 1 minus probability of A complement. So that's how we prove that probability of A plus the probability of A complement is equal to 1. Okay? And then, number 3, for any event A, the probability of A is always less than or equal to 1. Actually, this is correct intuitively because when we're talking about probability, we say, okay, the probability of this event is 50%, 90%, 99%, or 100%, but we cannot say, okay, this is going to happen like 110%, okay? But we can prove it as well. Now, based on what we got over here, we have that 1 is equal to the probability of A plus the probability of A complement, right? Now we know that the probability is always greater than or equal to 0 based on the axiom 1 we get over, axiom 1. So the probability of an event is always greater than or equal to 0. So if this part is greater than or equal to 0, I will say that this whole thing, the sum, would be greater than or equal to the probability of A, since the probability of A complement is greater than or equal to 0. Let me make this clear. This is A complement. Oh, A complement. So, since this part is always greater than or equal to 0, so this sum is always greater than or equal to the probability of A. So from here we have the probability of A is less than or equal to 1. That's number 3. Number 4. For any two events, A and B, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now we can prove this by drawing a Venn diagram. Excuse me. So if I gave you two events, this is A, this is B. Of course, this shaded area represents A intersection B. Now, how can we find the A union B first? So when we're talking about A union B, I want to say, okay, I will put A and B together, A plus B. Now, based on the graph over here, we can tell this shaded area contained in A and contained in B as well. So when we are adding A and B together, we're adding this intersection part twice. So this intersection part was added twice because this intersection part is contained in both A and B. So we gotta minus that once, A intersection B. The reason why we minus A intersection B over here is because the intersection part was added twice. And then we can tell that probability of A in union B would be equal to the probability of A plus the probability of B, and then minus the probability of A intersection B. That's how we got the number 4 here. And of course, there's a special case if A and B are disjoint. Then the probability of A intersection B is equal to probability of A plus the probability of B. And that's it. But technically, we usually minus the probability of A intersection B over here. Since A and B are disjoint, then we have this part is equal to 0. Since A intersection B is empty set. So of course, in this case, the probability of A union B would be equal to probability of A plus the probability of B when A and B are disjoint. Okay, this equation works only when A and B are disjoint. Okay. All right, that's for number 4. Let's take a look at number 5. For any three events A, B, and C, the probability of A union B union C is equal to the probability of A plus the probability of B plus the probability of C, and then minus probability of A intersection B minus the probability of A intersection C minus the probability of B intersection C, and then plus the probability of A intersection B intersection C. Now let's take a look at Y. So I'm gonna draw a Venn diagram over here. This is S, and let's say A, B, and C, right? So of course, when we're talking about the probability of A union B union C, we want, first of all, we want to add the probability of each of them together. Probability A plus probability B plus the probability of C. And then we can tell this part over here is A intersection B, right? When we are adding A and B together, we are adding this part twice. So we want minus one of them. And then let's take a look at the A intersection C. A intersection C is, let me use another color here. Is this part over here, right? This part over here. So when we're adding A and C together, we're adding this part twice. So we want to minus one of them. And then let's take a look at the B intersection C. B intersection is this part over here. Okay? So when we are adding B and C together, we are adding this part twice. So we want to minus one of them. Now, let's take a look at the center part. That's the very center part over here. This part in green is A intersection B intersection C. Now, let's take a look at this part. When we are adding A, B, and C together, we're adding the very center part 3 times. And then when we are subtracting the probability of A intersection B, A intersection C, and B intersection C, we are subtracting the center part 3 times. Then it's gone. If we don't add it back, we're gonna hole in the center here. Okay, that's why we wanna add it back, because the center part was added 3 times and subtracted 3 times afterwards, and that's why we want to add it back. If we don't, we're gonna hole in the center here. That's why. Okay, if this is clear, let's take a look at an example. So I gave you 5 events: E1 union E2 union E3 union E5 E4 union E5 is equal to simple space, and they're disjoint. Let the P sub n is equal to the probability of EI. So which means P1 is equal to the probability of E1, and P2 is equal to the probability of E2, and so forth. Now we have P3 is equal to 2P2, and is equal to 2P4. And P2 is equal to 2P1 is equal to 2P5. 2P5, I mean, is equal to P4. And the question is to find the probability of each event. So we want to find out the value of P1, P2, P3, P4, and P5. That's the question. So actually this problem looks complicated, but the truth is it's not at all. So what do we want to do here, since based on the two relationships given here, we want to convert each probability in terms of P1. So over here, we can have that P2 is equal to 2P1, right? And then we have P4 is equal to 2P2 as well. So P4 is 2P2, right? And then since we have 2P1 is equal to 2P5 over here, that means P1 or P5 is equal to P1. Now we can tell that P3 is 2P2. P3 is 2P2, and we want it to be in form of P1. I guess we should have P1 over here. P1. P2 is 2P1, P4 is 2P1. That's right. So that would be 2 times 2P1. We have that P3 is 4P1. And then we have, since E1, E2, E3, E4, E5 are disjoint and the union of them is equal to simple space, then we're going to have that 1 is equal to the probability of simple space, of course, and that is equal to the probability of E1 union E2 union E3 union E4 union E5. Since those 5 events are disjoint, then we're going to have this probability would be equal to P1 plus P2 plus P3 plus P4 P4 plus P5. And then we want to convert each of them into the form of P1. So of course P1 is just P1, and we know P2 is 2P1. And then plus P3, P3 is 4P1 plus 4P1 plus P4, which is 2P1 plus P5, which is P1. That's right. And then if we add them all together, we have this is equal to 10P1. Now we have 10P1 is equal to 1. Then we have P1 is equal to 1 over 10, which is 0.1. Once we have P1 is 0.1, we have that P2 is 2P1, which is 0.2. P3 is 4P1, which is 0.4. And then P4 is 2P1, which is 0.2, and the P5 is equal to P1, which is equal to 0.1. So that's pretty much how to solve this problem over here. And the key point is that we know those 5 events are disjoint, which means we can break this probability down into the sum of those 5 probabilities. And that's the key point. Alright, that's pretty much all about this video.